Hey, hi everyone, welcome to your ML Students YouTube channel. And from today's video onwards, we're going to start end-to-end NLP projects. So we'll be doing 5 NLP end-to-end projects. From getting data till model deployment, we'll do everything. So this is our first video where we'll be first getting the data and understanding the data and do some basic pre-processing on Jupyter Notebook. And slowly, we'll make it completely modular coding and proper way. Okay, so first let's see the data. You can get the link. I will provide the link of this data in the description box. You can go ahead and download it. So this is the data I have right now, and I'm going to use this data where I need to predict the genre of the movie from this 1000 character of the scripts. So first, before going into it, let's see the data. So if we come here, you can see the train data and your test data is provided for us. So I'll be downloading both of them, and let me just download that thing. It's downloading it, and this is the testing data. You just need to click on this button to download it. Okay, so both are downloaded. Now if let me I go back to my folders, so it's not actually by mistake I wrote in music genre. It would be movie genre. So movie genre. Okay, movie space genre. Okay, so now what you need to do, you need to create a folder called anything movie genre classifier or whatever you want to take. Now go inside the folder, do right click, go show more options, then go to this open with code. So we'll be writing all of our codes in Visual Studio Code, and we're going to see how we can implement end-to-end. As well as I'll do googling in front of you to show you how to find something. If you forget something, it can happen, you might forget some of the commands and methods. So using this googling technique also, you can get things very easily from the internet itself. So let's click on this open with code button first. Yeah, so right now you can see it's complete empty page for us. So first let me go to my download folder and let me bring all those data sets that I had. So I'll do Control C. I'll come back to my VS Code. I'll click here in this part, click here, then I'll do Control V. I think it should be fine. Okay, I forgot to unzip it actually. So let me first extract it. Extract all, extract. Okay, then this one also extract all, extract. So you can see both are extracted here, train CSV and this CSV, and I am going to take these two of them. Control C, go to this page, Control, and I will paste it. So I got my training CSV, and if I can go to download, go to my test CSV, I will take it. Control C, I will come back here and I will paste it. Yes. So let's see. Okay. So now what you need to do, first we need to create a virtual environment. So we need to create a virtual environment first, because if we create our virtual environment, then only we can do things properly, because we'll get a new environment where we can do all of our installations and everything. So let us go ahead and open terminal. So how can we open terminal? We need to go here, then go to terminal, then come new terminal. So we will get now from here. I am going to change it to command prompt because it's quite familiar to me. Okay, now we have this. Now let's create a virtual environment, and I am going to create a virtual environment of Python 3.10. So let's create conda create. So right now, as you know, right, when you create a virtual environment, generally your C drive will be automatically get full. But in my case, so as right now I have only C drive in my system, but I'm going to create that virtual environment in my current folder, so that tomorrow if I need, I can easily remove that also. So for that we need to go conda create -p, then give the name of the virtual environment. So let me give it as venv, then Python version. Right now I'm gonna use 3.9 and then -y. Why -y? Because when you are going to install that, you need to press yes or no that you want to proceed ahead for the installations or not. So right now I'm directly giving that command so that it's not gonna ask me next time when it is going to start creating the environment for me in the current folder path. So now press enter. Now it is gonna create the path virtual environment for me. So you can see now it's loading it up. So let's wait for some time. Yeah, you can see it's created. Now how can I act? If you go here this side, you can see this environment is created and is inside the current folder directory, right? Okay, now what you need to do, you need to activate the environment. How can I activate that? Iterate conda activate venv slash, just this folder path you need to give here. Make sure your command prompt in the current folder. Okay, so just click enter. So now you can see it's coming this one, right? So that means your virtual environment is being created now. So let me write clear, sorry, cls to clear everything. Now we can start working on it. So before starting with anything, right, first what I want to do, I want to create a simple Jupyter notebook and I'll write code to do some processing and everything, and later I'll make it a proper end-to-end with proper modular coding and everything, because first we need to know how the data is and everything. And Jupyter notebook is a good starting point for you to do all the experiments on the notebook itself. So what I'm gonna do, I'm gonna come here, new file. So this new file is going to create a new file for me, and the file name I can give experiment .ipynb, then press enter. So you can see this is the Jupyter notebook interface came up and I can write all of my codes here. So now first writing anything, I need to select the kernel, and I am going to select this kernel that I have created, right? So what I need to do, I need to click on select kernel, then I need to go to Python environments. Then you can see this is the current path, venv, then Python exe. This is what I wanted to use now. So click like this. So you can see it is selected. Okay, so now before starting any coding here, everything, we need to install few of the libraries here, because we have created a completely new virtual environment. That means you cannot even have pandas numpy also here, so we need to install all of them. So I'm going to create a new file, requirements.txt, and here I am going to write all libraries that I am going to install. So as of now I need 3 libraries. One is your pandas, 4 libraries, pandas, numpy, and I guess matplotlib and IPY kernel. So pandas numpy is for your data frame and numerical processing, matplotlib is for your data visualization, and IPY kernel, because I am using Jupyter notebook here, to use the Jupyter notebook I need to install this IPY kernel then only I can access the Jupyter notebook. I can run the codes and everything. So I will come here, maybe in the new cell I will create, and this is my command prompt, and I am gonna do pip install -r requirements.txt. Okay, hold on, maybe some glitch happened. Pip install -r requirement.txt and press enter. So you can see it's gonna install everything whatever I mentioned there, my pandas, matplotlib, now all the rest of the stuff will be installed automatically, and it might take some time to get all installation properly. So let's wait for that. So it's loaded successfully, right? So now let's start writing code for our end. So let's first import libraries. Right, import. A bit more zoom for you, I guess. I am not able to zoom it. Yes, that's fine. So as of now, I don't need that, so I can downgrade it. Now write import pandas as pd. Next, import numpy as np, as well as we need to import matplotlib.pyplot as plt. So these three things right now I am importing. Let me run this cell. It's running now. Okay, so we have that thing ready. Now what we need to do, we need to read the training data, right? Let's see how the data is. Read the training data, CSV. So train df equal to pd.read.csv, and here I need to pass the path of the CSV file. I'll go here, right click on it, click copy path, come here, double quotes and control V. You might see here that we have conflict. The name might not work properly here, so that's why I want to use R string. R, hold on, R, just a second. R, yes. So if I now run this, yeah, it ran successfully. Okay. Now let's see the head of the dataset. Head of the dataset, training dataset, right? So let's do training dataset. Training dataset. Train df dot head, maybe was 3. Okay. So you can see, right? Some AD death, maybe when wishing he was something. It's a thriller genre. T summa cum learn and all, and I'm about something is there for comedy. So, and we have respective ID. So so that means we have these 3 columns: ID, text and genre in the training data. So now let's see the shape of the data first. Shape of the training data set. Maybe I can do train.tf.shape. So this is going to give us the shape of the data. So if I run this, or if I do properly, print shape of the data is comma, then yes, save of the training data, right? Training data is this. So you can see it as 22,579 rows and 3 columns, right? Okay, now let's see how many genres we have exactly in our data set. Training dataset, right? So let's try to do it. That training df. So we know the column name is genre, right? It's genre, and if I do unique, and if I run this code now, you can see we have thriller, comedy, drama, action, sci-fi, other, romance, horror, adventure. So we have this many genres. Okay. So now if I count the occurrences of each genre, so count or the occurrences of genres in training dataset. So as we know, we can do using value counts. So I'll do value count dot value count value count. So now if I run this code, you can see the numbers, but it's not that distinguishable, right? So let's do one thing. Let's do plot dot bar. So now you can see, right? If you try to see now, for drama we have this. Drama is the highest one, then thriller, then comedy, then action, then sci-fi, then horror, then other, then adventure, and then romance. So yeah, now what you need to do, we need to first remove one column, right? Because if you see this train df, right? So this id column has no use in our case, right? We are more focused on this text and genre column. So let's first drop this id column. So command line drop unnecessary column named id. Yes, id column, right? So train df dot drop id x is equals to 1, and you need to do it like so. It is going to remove the column. If we now see the dataset, you can see this id is not there. Okay, fine. So now what we need to do, we need to do some pre-processing. So what kind of pre-processing we are supposed to do? We will remove stop words. So we'll try to handle our text data here. So for that we need a library called NLTK. So first we need to import it, and for importing we need to install it. So that's why I came back to the requirement txt, and inside NLTK library I have put the name of the library that I want to install. Then I come back here Again I click up arrow, again I click enter. Now it is gonna install NLTK library also for me. Oh, install successful. Fine. Let's come back to our case now. So let's import NLTK. Okay. Import NLTK. NLTK. Okay. As well as we need to download few things. Alright. But let's not download it here. Let's just run it. Okay. So now what we need to do? We need to do some pre-processing. So how do we do that? Let me explain. So first we need to import few things. What is those few things? First from nltk.stem dot porter import porter stemmer. So this library is gonna use doing stemming for us. Okay, you can see what stemmer based on the porter stemming algorithm. Okay, so this is I'm going to say run this code again, and let's come here. Let's see what porter stemmer does. Let's say I have an English word here. Let's say I am a goods boy. Okay, now I'm going to stem equal to, I'll call that porter stemmer class. Okay, I call that porter stemmer class, and after calling that porter stemmer class, what I'm going to do, I'm going to do stem dot stem. There's a method called stem that is going to do stemming for me. If I now pass my text input right and run this code, you can see it's now make it completely lowercase. I'm a goods boy. Now if I make it I'm a god boy, it's going to make all of them is a lowercase, right? Lowercase, and now it's coming like this. Now let's see what happens when we are going to pass this text. Maybe the this data first. Maybe the first your first row. Let's take it. How we can take it? For that we need to go to train df, right? Train df dot ilog. So we want to take first row and first column. So the basic implementation we are trying to do here. So we want the first row and that's the first column. So if I run this code now, you can see I got a big text here. So now what I'm going to do, I'm going to pass this text inside porter stemmer and let's see how it coming. Do the text pass and run this code. Okay, and let's see the difference between the real output and the stemming output. So we cannot see much changes as of now. So it's make it is a this or this full form. Okay, it's like this only. It's like capital letter made all of the small letters, like the way it did for my example text data. And if we see here, Here if you see, it did not do much changes, but yeah, it's worked actually. So you can see, right, this is our stemming doing its job here. So let's do one thing, let's remove all of them and let's start from here. So let's clean the dataset. How can we clean the dataset? So if we want to clean the dataset, we need to do few steps. What are the steps? We need to remove stop words, we need to remove punctuations, as well as we need to do stemming, right? So for that, let's first write a comment cleaning the dataset, right? So let's take corpus, or let's take our corpus and let's take stemmer equal to put stemmer, because we are going to do stemming in one go. So I'm going to initialize the class here only. Initialize the stemmer class. Initialize the stemmer class. Okay. So let's now loop through. For row in trinity the shape 0. Why 0? Because we want to loop through each row wise, right? And we want to do all the changes in each row wise. So what all changes we want? First of all, we want to remove all the special characters from our dataset, right? So for that, we are going to use your regular expression. So let's go up, maybe up. Then I'll do import array, that is your regular expression, and then I am going to implement that here. So let's come here. Let's work doing like data equal to array dot sub, and then need to get the pattern, right? So the pattern, what is the pattern? We want everything except anything else, this A to Z, right? So we do not want anything except A to Z. So that's why we are given this, and we need to make this pattern inside a quote, right? And then what we need to do, we need to pass the string, right? String equal to the reindeer ilog row and the first column. Okay, so I think our first work is done. Removing extra non-alphabetic characters. Okay, now what we need to do, we need to now converting all of them into lowercase. So now again data equals to not data, because we have this text actually and this one only. So let's do like dot lowercase data equal to data dot lower so lowercase also. Now what you need to do, you need to tokenize them, right? Tokenizing words, right? So how can I tokenize the words? Token what equal to lowercase dot split. So we are splitting based on space is in our data as of now. So after doing that, let's do it till now. Okay, let's do it till now. Let's see how it is going to come. So once we are done with that, right? So we need to do few more things. We need to remove stoppers also from our dataset, right? What are the stoppers? See, if I go to Google and if I go here, what is stoppers? If I search what are stoppers, if I go to this Wikipedia, so stoppers are the words in a stop list which are filtered out or stopped before or after the process of natural language data because they are deemed insignificant. There is no single universal list of stoppers used by all natural language processing tools, nor any agreed upon rules for identifying stoppers, and indeed not all tools even use such a list. Right? So you can read this, and from here you can get the idea that stoppers as this they are deemed to be insignificant, and that is why we are going to drop those stoppers. But how do you know what all are our stoppers? So for that you need to do few things. Come back above, maybe there you can come back. Let's try to download this stoppers. So how can we download the stoppers? So I need to do nltk dot download stoppers. If you do this, it will be able to download the stoppers for you. So how do you store those stoppers? Once your downloading will be finished off, you need to do from nltk dot corpus import stoppers, and I run this code. Now you can see it's downloaded, right, and installed all are updated. Now see stopper. Let's see some stoppers. So how you can see stoppers? You can see I've imported stoppers right here. Now just copy the stoppers. Control C, Control V, stoppers dot words. So what kind of stoppers it new need? What language you want? Let's say English. Okay. And if I run it, see I, me, my, myself, we, are, ours, ourselves. These all are stoppers. So let's see stoppers for any other language. Let's say French. French. See, these are the stoppers for French language, right? If I go for Hindi and run this, so I guess they do not have for Hindi. Okay, maybe they don't have for Hindi. Do they have for Bengali? I'm not sure exactly. Okay, so yeah, for Bengali also they have this stoppers. Okay, right? If you are Bengali, you'll be able to read it, or else I will leave it. So these are the examples of stoppers, and if there are any such of, like if I make it English only and if I run this code again, so if in my tokens I find any one of this text or token, we are going to remove them because they are stoppers. We do not need that. They are insignificant in our NLP use case, right? So let's do that. So first what we do, we'll try to remove this also, and then we'll come below. So we are going to write one simple logic here. So removing stoppers, that should be our next step, right? So how we are going to remove stoppers? So removed stoppers equal to, we'll run through each token what. Okay, and if what not in, that what we are taking, if that what not in, I think we need to define here stopwatch. I guess we don't need to define it here. Let's do one thing. Let's try to come here and let's write remove stopwatch. First what in token what, if what not in stopwatch, stopwatch dot, if dot in stopwatch dot what's English. Okay, I hope spelling is correct. Check stopwatch. Yes, it's okay. Okay, if that what is not in this, then only we should be able to print that, right? So let's do what simple basic list comprehension we did here. Okay, so once we have those, last step we are going to stemming the words or tokens. So for that already we have imported co-customer. So stemmed words equal to, so what I do, I will try to again loop through it for what in removed, if not if I did it, it's auto completion happening here. So I am gonna do stemmer dot stem what, right? So then what I am going to do, I am going to joining the stemmed works back to string, words back to, okay, back to string, yes. So how we can do that? So for that we need to do that final maybe final script equals to stem. I guess I need to join with a space, dot join stemmed what, right? So it is going to join all of them, and last we are going to append all this in our corpus, appending and final corpus is now corpus dot append final script. So right, you can see it's now going to append that. Now let's run this code, but before running this code I would like to do another thing. What we can install the one library called tqdm. Okay, because this library we can use to see our loading, how much time it might take to get this all processed on the training data. So let's do again pip install -r requirement.txt and enter. So it's installed successfully. Now let's come back to our code. Let's go to our import section. Let's import this tqidm. Here from tqidm, import tqdm, right? Okay, now come back to our code. And let's do, I guess tqdm would work here, and think so. I run this code now. So we are getting error here. Tqdm is not defined. Okay, I forgot to run the cell. So I need to run this cell first. Now I need to run this cell. Okay, again we are getting error, type error. Okay, so it would be in range, sorry, range, I missed that, range wala thing. So let's do range. Now let's run this code. So again we are getting error. Okay, I think I forgot to pass. I forgot to pass what to replace with. My bad. So I have to pass replace. So I want to replace with a space. So what I forgot to add here actually. So if there is something except capital A to Z, like non-alphabetic characters. So I'm gonna replace them with a space. Okay, now it should be fine. Run this code now. Okay, so you can see now it's a loading, and as well as you can see this loading also, how much time it might take to complete this entire chapter. So we'll wait for that and then we'll discuss about it. It might take some amount of time for our end. Okay, so you can see that it has been completed its process, and let's now see the how corpus looks like. Corpus, and if I now run this code, now you can see the complete corpus, right? We have the complete corpus here. It's a big corpus here because we had lot many data sets, right? So this is what was my like demo for you guys. Now in the latest video I'm gonna continue from this part. So thank you for watching this video, and please don't forget to share your feedback in the video comment box only. Thank you.